This is a quick demonstration video on how to draw this park pavilion using two-point perspective. I'm going to run through a series of steps that are written on the assignment sheet that I emailed to you on Saturday morning. But this video should help you to apply those steps to the real life scenario that you are going to be observing when you come outside. First, you'll notice that Loyola University is back here. The playground that we drew previously is right over there. So this pavilion is located a little bit further into the park than where we drew initially. The first thing that you need to do in order to start this drawing is align yourself with a corner of the building. At this angle, you can see a lot of different corners, but I'm taking note that this corner right here is sort of the leading edge. Away from this corner, I can start to see receding lines moving at a diagonal, first to the right, and then off to the left, like so. You can choose to draw from any of the four corners of this building, but again, just make sure that you can tell where your front corner is located, and then you can see how receding lines are moving away on the right and on the left. Once you've aligned yourself to a leading corner of the building, again, any of the four corners are fine, you need to locate your eye level. By locating your eye level, you will be able to find the horizon line that you need to include in your drawing. So I'm going to, usually I would do this with a ruler, I'm going to use my pencil for the time being. I'm going to look and see where receding lines on the building appear to be straightening out. So here, there's a slight bit of lift to the angles that I'm looking at, same on that bit of stone. Up here, the angles are definitely falling below the straight line of my pencil. But right about here, I can see some of those angles pretty close to a straight line. That tells me that my horizon line runs through the building and out onto either side, like so. Once I've found my horizon line, I need to observe a couple of pieces of dependent information. So I need to find the vanishing points on the left and on the right of this building. This is going to be a little bit tricky to show in video, but bear with me. Let's start with the left side where I can see slightly steeper angles. In order to find my vanishing point, this is actually something I need to observe in real life before I can put it accurately onto my page. So I'm going to follow, again, using a ruler is going to be really, really helpful. I'm going to sort of trace the receding edge on this left kind of roof line. I'm going to look for the point at which it seems to correspond to or converge on my horizon line. So if my horizon line is like here, and I'm looking to see where receding edges converge, I can test a variety of receding edges, looking for that point of convergence. It looks like my vanishing point is just a bit off the camera. I'm going to shift slightly to show that. I think we can say that maybe my vanishing point is right about here on this car. So I'm going to fix that landmark in my memory. And then I'm going to go ahead and find a ratio that communicates where that vanishing point is located. So I'm going to use the height of the front corner of the building. This is a really easy point to return to. Height, location of the corner, and I'm going to take the height and measure it over to the location of the vanishing point. So I have height of the front corner, 1, 2, slightly less than 3 times. This is really tricky because I'm dealing with the camera perspective. So I'm going to try it again and hope to get a repeated kind of measurement here. Height of the front corner, 1, 2, about 3 times. I would write that ratio down. The location of the vanishing point on the left is 3 corners away or 3 heights away from the corner. You have to refer to the corner a lot. Don't be confused, it serves multiple purposes. I would do the same thing on the right. In this scenario, I would have to turn my camera a lot in order to show you where the vanishing point is. This angle is just slightly more relaxed than the ones over on the left are. And so this relaxed set of angles means that my vanishing point would be like pretty far away, maybe over here or even more. Don't be surprised if you have a viewpoint like this where you have a really relaxed side of the building. That vanishing point is going to be very, very far away, but you can locate it with the same method. So I would do the sort of imaginary line drawn out through space, looking for where those converging lines meet on the horizon line. Once I find that landmark, I would try to find a ratio for how it relates to the building, height of the corner, and then how many times does the vanishing point, or does the height of the corner fit before I reach the vanishing point, which again would be pretty far off camera at this point. All right, for the purposes of making this video, I have had to move indoors, but I'm still gonna address what you do after you have located in real life the location of your vanishing points, that moment in the landscape where you see receding edges of the building converging on your horizon line, and you have used the height of the corner of the building to sight and discover how far away that point of convergence is from the corner of the building. Once you've observed those pieces of information and written them down, you have to then translate that information to your drawing in order to help replicate what you're looking at. So here's how I would go about that process. I've got my piece of paper. I have gestured in vanishing points near the edges of the page. I'm not saying that I won't shift these. There are conditions under which I would potentially shift these, but I want to start out by having them really almost at the edges of the page because this is going to be a small drawing, and within that limited size, I want it to be as big as I can allow it to be. So I'm going to just in the middle part of this video here, obviously in the first part of that video, I went through a process of coming up with an actual ratio for the location of the vanishing point on the left. And then I indicated that my right vanishing point would be very far away. For the purposes of this little sort of momentary interlude or this drawing portion, I'm going to just use 2 really simple ratios that are chosen specifically for right now and are unrelated to the first part of the video. And that's just for the sake of the clarity of moving through this little drawing component. It'll be loosely related to the viewpoint that I had in the park, but not exact. And obviously you guys are going to have different ratios when you're looking. So follow the process, but not necessarily the numbers as usual. All right, I'm going to say for the purposes of this little demo that my vanishing point on the left, so left, vanishing point, left, VP, is related to the corner of the building. I'm going to say that the height of the corner, which is my 1 value, fits in comparison to the left vanishing point, we'll say 2.25 times. Okay, we're going to say that I have discovered a vanishing point on the right that fits or is defined by is 7 corners away, 7 heights away from the corner of the building. So again, we'll do corner 1 fits into the location of the right vanishing point 7 times. So what has to happen on my drawing is I need to place this leading corner, the height of which needs to fit 7 times over in comparison to the right vanishing point, and 2 1/4 times over to the left. So I start with just a little bit of a gesture, and I'm going to test height of the corner compared to the right vanishing point. 1 to 1, 2, 3, 4 and a half. So the corner may be very much too tall because I am not close to my 1 to 7 ratio. I'm gonna do just a little test run here on the left, just see how I'm doing. 1 to 1 and 3/4. So the corner just needs to be shorter. I am going to come back and test and make sure that my horizon line is correctly located on the height of the building, but I'll get to that in just a moment. So I've shortened the height of the corner here just a little bit. I'm gonna try again. 1 to 1, 2, 3, 4, 5, and a little bit. So I'm getting closer, but I'm still not there. One to 1, 2, so still too short as far as the left is concerned, or too tall rather. On the right, 1, 2, 3, 4, 5. So this is going to be, like I said, this is going to be a really small drawing. I've shortened things considerably. Let's see if this is going to work. 1 to 1, 2, 3, 4, 5, 6, 7. I'm in great shape on the right side. That checks out. What's going on the left? 1 to 1, 2. Okay, and that's just a little bit too far. It's centered just a little bit too much. From here, I have 2 options. In this example, because I have enough room, it would really be easy for me to just move the vanishing point over a little bit. 1 to 1, 2 1/4. So that would pretty much do it. But if moving the vanishing points is gonna really condense their placement, then you can also, and I'm gonna demonstrate this too. This is gonna be a very delicate little adjustment. But if I move the corner over just a touch closer to the left vanishing point, and I make it just a hair taller, I should be able to maximize the size of the drawing. Still, by moving that over, still have a vanishing point on the right that is 7 lengths away. 4, 5, 6, 7. So I'm gonna go with this. Move that vanishing point out. One to 1, 2 1/4. Okay, and my left vanishing point stays put. So again, your goal here is for the height of the corner to be correctly related to the placement of the left vanishing point and the right vanishing point. And as you search for those ratios, you do have to do a little bit of gesturing and adjusting and revising until these relationships are correct. In the observation-based video, I believe I found the horizon line was maybe just a little bit higher up on the building. I think I'm really close, but if I need to adjust that, right, I can add a touch of height, adding that to the bottom, take a touch off the top. So I don't want the height of the corner to change overall, but I do want a horizon line that matches up with the rest of the building. In a moment, you're gonna continue to watch the rest of the video, what happens after you have this information in place. So we'll switch to that, and then I'll draw just a little bit more. So after I've got the vanishing points fixed on the horizon line in a way that is proportionate to the height of the building, this becomes a much easier drawing, and the sort of strengths of two-point perspective starts to take over. So you'll just want to start to pay attention to which lines, which edges on receding planes are related to which vanishing points. There's a lot on this wall that goes back to the left, but from this perspective, also some nice information that moves to the left vanishing point. The interior here, this wall, bottom and top edges relate back to the left vanishing point. A lot of information is just going to be stuff that you find by sighting. So how wide is the overall width of the building compared to the height of the corner? And within that, how wide is this side of the building compared to the height of the corner? How wide is this side of the building compared to the height of the corner? How wide are these smaller forms and spaces compared to the side that they fit into? You have to do a lot of work to figure out the widths and the way that they're arrayed in here, but most tops of these forms are things that you can figure out using some simple heights located right up here in this foreground sort of foremost object. The roof is a separate undertaking. Once I have some of this architectural information figured out, I want to understand how tall the roof is. Then I want to know where is the peak as far as how it relates to the forms underneath it. How does it stack compared to what it's on top of? This roof line up here is going to relate back to your vanishing point on the left, but every other angle has its own shape, and you just want to sight to figure that out, gesture it, refine it. None of these three ridges is related to the vanishing points on either side, only this up here. There's plenty of complex information, but as long as you keep track of which lines should be vertical, how widely things should be spaced apart, how tall different points should be, and then a clear sense of what information relates to what vanishing point, this drawing starts to come together fairly efficiently.
All right, so with information like how wide is the building overall, and then how many times does the side of the, the left side of the building fit into the overall height of the corner? How many times does the right side of the wall fit into the height of overall corner? Here I'm going to, again, I'm working from home, and so I'm modeling these steps rather than precisely replicating the building in front of me because it's not in front of me. But I'm going to say, for my purposes, let's say that I have found that the width of the right side equals 2 corner heights. That would be 1 to 1, 2. I can make a mark here, like so. Let's say that I have found that the right side of the building is 1 to 1 1/4. 1 to 1 1/4. Okay. Once I have those widths in place, I'm going to determine the height of the back corner of the wall by relating to my right vanishing point. And then the bottom of that wall goes from front corner to right vanishing point. Left wall. Oops. I'm going to just adjust that a little bit. All right. Just clean up some of that line work. And then I can start citing for and looking for information like how wide is this back wall? How wide is this sort of front corner area? How wide do I see this side of the front corner? How about the back corner? The space in between these, the locations and widths of these pillars. I'm gesturing right now, but all of those little widths are things that you can cite. And then you're looking to see, you know, like almost all diagonal lines on the left wall are going to go back to the left vanishing point. The lower half of the beam up here. I know there aren't any windows here. On the right wall, you'll look and see the beam is falling back towards the right vanishing point. There is some architectural detail right here. Top and bottom edges of stuff on this wall will go back to the right vanishing point. From the perspective that I was drawing in the park, the interior of this pavilion, there's a wall like so, and it has some benches here, right? A little opening back there that you can't totally see. That wall right here is parallel to this wall, which means that I can relate that corner carefully back to my left vanishing point, and then up at the top of the interior wall, I would also find a recessive edge that goes back to the vanishing point on the left. Last thing to be mindful of, I'm just going to draw through this really quick so you guys know to look for it. The overhang of the roof, this edge relates back to my vanishing point on the right, whereas this overhang would go back to the left, right. That's not at all sighted correctly. Left. Just looking at behavior here. The roof itself, I would want to cite how much taller than the front leading edge here is the peak of the roof. Maybe that's the height. And then how does it interact with the information below it? So how far to the right? Let's pretend that it's right here. That very top ridgeline from the angle that I was looking at would fall back to my left vanishing point, but then the sort of irregular long slopes of that roof have movement all their own. All right, good luck, y'all. As long as you can observe really consistently, just keep a close eye on what information relates to which vanishing point. You can always cite to find that out. Hold up your ruler, follow recessive edges, double check your angles. You don't have to rely on gesture. You can use 2-point to guide the movements of recessive lines, and then cite heavily for unrelated widths in particular. How is everything spaced out? And then occasionally, if you have an interior height or extra height, as the case may be, cite to find that as well.